All right, welcome to the next section. So we're continuing on the similar path, talking about relationships, talking about joins, more complex data, multiple tables, and connecting those tables, drawing lines between them. However, we're now moving on to our next relationship, which is the many-to-many relationship. So we saw how to do a one-to-many, which is a pretty standard relationship, and it's pretty common. Many-to-many is common as well, maybe not as common, but still very, very common. So we're going to see how to do it, and the reason that I saved it for last is that it's a little bit trickier. It's not hard, I don't want to scare you away, but you'll see there's a little more setup involved. And then once we've discussed on a high level how many-to-many relationships typically work, we're going to implement one using some relatively complex data that I spent way too long creating, and then we'll do some problems together. So this section will actually serve more as a code along. So I would encourage you, if you don't typically, I encourage you to follow along. We're going to use some relatively complex data, like I said, and we'll just go through it, do a couple exercises together, and I'm going to use it as a way to illustrate how joins work on a many-to-many relationship. So let's start in this video just by talking about the many-to-many relationship. So we kind of discussed it briefly in the last section, but here are a couple examples. So books and authors, harkening back to that last section where we saw books, a book can have multiple authors, right? There are lots of books that are written by co-authors or teams of, if it's a collection, if it's an anthology, there might be 20 authors. And each of those authors can then have multiple books. So it's a many-to-many relationship. Books can have many authors. Authors can have many books. Or another common example is blog post or some sort of content, whether it's an Instagram photo, a Tumblr, whatever you call it, a Tumblr post, or just a traditional blog, some sort of content, and then tags. Tags, by that I mean things like, sunset picture, or there's some really silly, like van life, if you're familiar with that hashtag. Or I do a lot of photography, so I see a lot of tags that are things like masterpiece landscape photography, and then Insta good if you use Instagram. There's all these different tags that are out there, and each post can have multiple tags. So, there's a limit sometimes, but on Instagram you can have 30 hashtags, I think it is, on a photo. And then each of those tags can then have as many posts or photos as necessary. So that's another example. And the final example I have here is students in classes. So we're talking about like maybe college students or university students, where students have multiple classes. They pick their classes at the beginning of the semester. One student must have multiple classes, unless maybe it's your last semester, but you have multiple classes that you go to, that you're related to, and then each class is going to have multiple students in it. And that's a many-to-many relationship. And the one that we'll be working with in this section is actually not listed here. It's a little different. And to start off, I want you to imagine that we're building a TV show reviewing application. Like, yes, I know we don't need any more of those, but imagine something like Internet Movie Database. Very, very simple version, though. But we're working with TV shows exclusively. And the key idea is that we can have someone who signs up as a reviewer. We can have TV shows that, let's say some of the ones I'm using, Fargo, the TV show, Archer, General Hospital, any series. And a reviewer can then rate any of those series. So I could sign up and rate Archer as a 8.5 out of 10. So to accomplish this relationship, a many-to-many relationship, where we're basically associating users, or reviewers we'll call them, with TV shows, we need to actually use 3 tables. We use what's known as a join table or a union table. So we have our series data up here. So these would be the TV shows. And then down here, we have our reviewers data. So these would be just names in our case. We'll keep it very simple. This will be Colt, or this will be Charlie, or whatever it is. But the way that they're connected is through a third table, through a reviews table. So this will make sense when I show you the schema in just a moment. But think about it this way. Series exist on their own. They're just TV shows. Reviewers exist on their own. They have nothing to do with a series out of the box. It's just someone's name, but they then are associated through this reviews table. So this reviews table will have information on the TV show that's being reviewed, and then the reviewer who is doing it, as well as a third piece of information, which is the rating. What's the number, the numeric representation of that review? So without further ado, let's take a look at our schema. We have 3 tables. Reviewers over here with an ID, primary key, first name and last name. And of course, in a real application, we would have more data here, right? We would have email. We'd be storing our password in a safe, protected way. We would have things like registration date, maybe last active, all that kind of stuff. But to keep it simple here so we can focus on the relationship, focus on the joins, I'm only doing first name and last name. Then we also have series. And, this is something I actually debated. The plural of series in English, modern, traditional, spoken English, is just series. However, a lot of people would argue that we should name this table series with an ES on the end, just to make it clear that that's the table name. I'm not exactly a fan of that. It's really determined by the project or the team you're working with, or by you if you're working on your own thing. I've worked on projects where we had to abide by that, where the plural was always with an S afterward, even if that meant mouses instead of mice. But I'm going to leave it as series, just because I think it's simplest. So series has a primary key ID, a title, so that would be Fargo, which is a TV show as well, really good TV show actually, not just a movie. So Fargo or Halt and Catch Fire, Seinfeld, and then the release year, so 2014 or 2002 or whatever it is, and then a genre, which we're going to keep very simple. We're only going to have animation, comedy, and drama. So just a couple of examples of genres. But again, these on their own are just separate entities. Where they're joined is through this third reviews table, which is what's known as a join or union table. It's connecting these two. And the way it's doing that, well, first of all, it has an ID. Nothing special there. Every review has an ID. There's a rating. So this would be, 5.0 for a mediocre show, or a 9.9 for a fantastic show. And then the series ID. So that's going to be a foreign key pointing to the series table. So what series? Is this Fargo? Is this Seinfeld? And then the same, well, not the exact same, but the same idea for reviewer ID. It's going to be a foreign key pointing to the reviewers table, the ID field. So then a single review will have an ID. It will have a rating, 9.0, a series ID, like 1, and then a reviewer ID, which could also be 1. They're pointing to different tables. So this is a centralized repository or centralized place for our information to be stored. It's connecting these two tables through this table. So hopefully you can see how this is going to work. Basically, reviews on its own is going to be a pretty ugly table to look at. It's just going to be numbers. It will have an ID, which is a number. Rating is a number. Series ID is a number, and reviewer ID is a number. So looking at it on its own is actually going to be very confusing. It's not going to make sense. So we'll have to use joins to be able to understand things, so that we could use a join to replace series ID with the name of the series, so that it says Fargo instead of 1. Or it will say Blue Steel instead of reviewer ID 3, and so on. So that's our basic idea here. Here's an example with some simple data. Very, very simple, 2 reviewers. So we've got Blue Steel and Wyatt Earp, ID of 1 and 2. Then we've got 2 series, Archer and Fargo. If you're not familiar with these shows, don't worry. That's not necessarily relevant. Archer is animation, released first in 2009. Fargo is a drama with a little comedy, released in 2014. Archer has ID of 1. Fargo has ID of 2. So they're independent. But then our reviews table. Well, somebody reviewed something with a rating of 8.9. The person who did that has a reviewer ID of 1. So that is Blue Steel. So Blue Steel reviewed something and gave it an 8.9. Well, what did she review? Whatever has series ID 2. So Fargo. So Blue gave Fargo an 8.9. Then we have a 9.5 down here, and the reviewer ID is 2. So that's Wyatt Earp, this field or this row here in reviewers. Wyatt Earp also reviewed Fargo because it's ID 2. As we can see, corresponds to Fargo. So essentially what we're storing here, Fargo has been rated twice. Once by Blue as an 8.9 and once by Wyatt as a 9.5. So as you can see, the data is not that pretty in this table, and this is only with 2 reviews. We'll be working with somewhere around 100 reviews, which is a lot of data to look at on its own. And so we'll really be focusing on making that data understandable, readable, which is really the point of this entire exercise. So we're pretty much done here in this first video. We didn't actually do anything except discuss our schema. But in the next video, we'll actually go about implementing the tables and inserting some data on our own.